Around the world, at any given moment, 2,000 thunderstorms are churning through the sky, producing up to 100 flashes of lightning every second. Lightning might seem like something we've got all figured out, but in fact, the details of the physics behind those flashes is still a bit of a mystery. Los Alamos National Laboratory studies lightning because it produces signals similar to those from a nuclear explosion. That understanding is helping us develop better instruments for nuclear test ban treaty monitoring and, in the process, allowing us to answer a lot of questions about lightning itself. For example, what initiates lightning? Some say it's caused by cosmic rays scattering enough electrons through the atmosphere to get a current going. But recent research conducted by Los Alamos scientists and their collaborators strongly suggests that lightning actually arises from areas of extremely high, localized electric fields, not from the long paths that a cosmic ray-induced event would require. We're also learning that lightning can be a useful tool. Research shows that enhanced lightning rates can indicate severe weather. Maybe someday our understanding of lightning will allow us to use space-based lightning detection to predict tornadoes and other severe weather events with enough lead time to prevent casualties. Until then, Los Alamos will keep studying and better understanding those mysterious, energetic streaks in the sky.
Ben Franklin began the study of lightning 260 years ago, but to this day, scientists still don't fully understand how it forms. Sure, the basics are known. It's like a zap of static electricity, except on a much, much larger scale. In stormy updrafts, raindrops and ice particles rub together. Some become positive and others become negative. Then they're pushed apart by wind within the storm cloud. As a result, the cloud ends up with areas of different charge. Lightning is the spark that jumps between these areas. These sparks can also fly between the negative areas of the storm cloud and the positive areas on the ground, say through a tree or a golf club. Simple, right? But there's a problem. The electric fields measured in thunderstorm clouds typically aren't big enough to trigger a spark. So what sets it off? Maybe cosmic rays. The idea goes like this. Cosmic rays, which constantly bombard the Earth, produce fast-moving, highly energetic electrons. These electrons collide with air molecules, which produce more speeding electrons, and so on. This process is called runaway breakdown and leads to an avalanche of energetic electrons through the air. These electrons forge a conductive path in the air, which triggers the discharge of lightning. Of course, the theory hasn't been proved, and there are other ideas for sparking mechanisms as well. It will take more work to fully solve the puzzle of how lightning forms. In any case, remember, the next time you get zapped pulling on a wool sweater, it just means you momentarily caught a little bolt of lightning. For Scientific American's Instant Egghead, I'm Philip Yam.
Welcome to the Severe Storms Research Center out here at Cobb County Research Facility of GTRI. I'm John Trostel. I'm the director of the lab. The purpose of our lab, being one of 4 state program offices, is to look at severe storms in North Georgia and come up with new and innovative ways of both predicting and tracking those storms. There are several major programs that we're involved in right now, including the North Georgia Lightning Mapping Array, which consists of 12 stations scattered around Metro Atlanta, which measure total lightning. Total lightning is a combination of both cloud-to-cloud lightning and cloud-to-ground lightning, and has been found to be a reasonably good precursor to severe storms. The data now is flowing into the National Weather Service and being used operationally. Second use of it is to calibrate one of the most recent geostationary satellites that has been put in orbit. That satellite has what's called the Global Lightning Mapper, and our lightning mapping array is providing ground truth for that satellite component. Another program that we are pursuing here at the SSRC is infrasonic detection of storms. To this effect, we have 12 infrasonic sensors also that we're beginning to develop into arrays that we can deploy and try to detect storms.
Hi, I'm Pierre-Luc Vigneault, Product Manager at Future Electronics, and today I'm here to talk to you about the AS3935 Franklin Lightning Sensor from AMS. Named after Benjamin Franklin, it's the world's first IC that is able to detect both ground strike and cloud-to-cloud lightning with distance-to-storm calculation, starting from 40 kilometers down to 1 kilometer. It's also able to reject disturbances from man-made signals such as motors and microwaves. The AS3935 Franklin Lightning Sensor can be designed into applications to provide advanced warning of approaching electrical storms, giving people extra time to prepare and take shelter as needed. With multiple low-power modes, a listening mode current consumption of 60 microamps, and housed in a 4x4mm 16-pin MLPQ package, the AS3935 can be easily integrated into a variety of portable or outdoor devices, such as golf carts, watches, cell phones, handheld GPS devices, as well as permanent installations such as weather stations, pools, and outdoor sporting venues. A typical application for the AS3935 requires a simple microcontroller with a SPI or I2C interface and a few inexpensive passives. The AS3935 also has an evaluation kit which includes the following: 2 PCBs, batteries, a flash drive with software, source code, schematics, and Gerbers. The sensor PCB features the AS3935 IC, a graphic LCD display, a buzzer, and a USB connector for data logging. The second PCB is a short-range lightning emulator board that will help emulate a strike at far, mid, and short distance, as well as noise and man-made disturber generation. The AS3935 sensor took 4 years to develop and has undergone multiple field trials in Finland and Florida, having a close affiliation with the Florida Institute of Technology, one of the leading research institutions in the field of lightning physics. But don't just take my word for it. Order a demo board from futureelectronics.com, keep it handy the next time a storm strikes, and see for yourself. Thank you.